Welcome to this tutorial on the use of Excel when analyzing physics lab data. This presentation is intended for students who are taking their first physics lab course, which may be a high school course, a college course without calculus, or a college course with calculus. In a typical physics lab, students measure some dynamic variables, perform some error analysis on the measurements, calculate some results using their measurements and estimated errors, make graphs that depict trends in the results, and compare results and trends to theoretical expectations. Lab work is reported in a graded paper that contains explanatory text, data tables, calculations, results, observations, and conclusions. In most physics lab courses, the expectation is that the data organization, error analysis, calculations, and graphical analysis will be performed using Microsoft Excel. The data, results, and graphs can be copied from Excel and pasted into the lab report, which is usually written with Microsoft Word. Many, if not most, beginning physics students enter physics lab without any prerequisite knowledge of Excel functionality beyond the ability to perform basic arithmetic using columns or rows of numbers. Physics lab is often the first time that a student is exposed to some of the advanced functionality of Excel. About a year ago, I returned to physics teaching following a 35-year private industry career. Like all teachers, I want all my students to be successful, so I am always looking for causes of failure and then seeking to teach so as to eliminate failure and maximize physics learning. It has been my observation that the physics lab course curriculum assumes that the students either enter the course with extensive Excel knowledge or that such knowledge is self-evident so that students will acquire it by playing with the program and self-teaching. In other words, Google it. This is a bad assumption. Struggles with Excel learning while simultaneously starting a very unfamiliar discipline of physics can be overwhelming. We need to teach Excel techniques so that students can eliminate struggles with the mechanics of data manipulation and can be freed to focus on the physics lessons that the labs demonstrate. That is our purpose in this presentation. In this presentation, we will present step-by-step instructions for the following subjects. First, we'll set up data in a table format so that it is organized correctly for conducting calculations, making graphs, and copying the tables into the lab report. Then we'll calculate data averages and standard deviations of data. Data and calculated results will be graphed with error bars. Graph data will be fit with a straight line, and the formula for the line will be displayed on the graph. Finally, data tables and graphs will be exported to the MS Word lab report. Throughout this presentation, we will do the Excel manipulations using an example experiment. The purpose of the experiment is to test the theory that the vertical and horizontal motions of a projectile are independent. This means that the projectile's hang time does not depend on the horizontal speed when the projectile is launched. It also means that the gravitational acceleration can be determined by measuring the projectile's range at various launch velocities. A graph of range versus launch speed should be a straight line, and the value of the gravitational acceleration can be calculated from the slope. The experiment procedure is pretty simple. We start a ball rolling on a ramp from a marked position. We measure the delta time as the ball rolls over the marks that are d centimeters apart. We can determine the launch speed from this measurement by simply dividing d by delta t. We measure the range, r, and then we repeat from the same starting point 3 times. We repeat all of the above points for 4 different starting positions on the ramp. That way we have 4 different starting speeds. Let's begin by setting up a table where we will enter the data and perform calculations. There will be 4 different starting points. So let's plan on having one row for each starting point. The first column will be the starting point value. This will identify the case. There will be 3 trials. Each will have its own time measurement. So the next 3 columns will be the trial time measurements. The column after that will be the average value of the 3 time measurements. And then we will need to have a column for the standard deviation of the time measurements. When these columns are completed, there will be enough information to calculate the velocity and its standard deviation. So they will be the next 2 columns. The range is measured for each of the 3 trials. The next 3 columns are for the trial range measurements. These will be followed by columns for the range, average, and standard deviation. Enter column headers in the first row according to this description. The screenshot below shows how the table will be set up. Now begin the case number 1 trials. Roll a ball from the starting point. Measure its time to roll the distance between the marks on the tabletop and measure the range. Enter these measurements in the trial number 1 time and range columns. Then run 2 more trials for the case number 1 and record the time and range values in the first row of the table. Repeat this procedure for the other 3 cases and record the time and range data in the table as shown in the picture below. Next, we want to find the average value of the case number 1 time measurements. This is done by entering a formula into the row number 1 cell for the average time. Click on the cell. Then enter an equal sign. This tells Excel that you are going to enter a formula to calculate the cell value. After the equal sign, start typing A, V, E. At that point, a list of functions will appear. Double-click on Average to select it. Then use the cursor to select the 3 cells containing the times that are to be averaged. The cell range will be shown in the formula. Hit the Enter key, and the average value will appear in the cell. Now calculate the standard deviation of the time measurements in much the same way. Click on the cell for standard deviation in row 1. Start typing equal, then STD, and at that point a list of functions will appear. Pick the one that says STDEV, meaning a shortening of standard deviation. Double-click it. Then highlight the 3 cells that contain the times, and the range will appear in the standard deviation function. Hit the Enter key, and the standard deviation calculated value will appear in the cell. The time averages and standard deviations for the other 3 cases can be obtained by copying and pasting. Select the row number 1 average and standard deviation cells that we just calculated. Select Copy on the Home tab or simultaneously press Ctrl-C. Use the cursor to highlight the block of cells that are the average time and standard deviation cells for the other 3 cases. Select Paste on the Home tab or simultaneously press Ctrl-V. The cells will be filled with the average time and standard deviation values. Follow the same procedures to calculate the average range and the range standard deviation for case number 1. Then copy and paste to fill in the average range and the standard deviations for the other 3 cases, just as we did with the time data. The average velocity for case number 1 is the distance between the marks divided by the average time. The distance was 50 centimeters or 1/2 meter. Select the case number 1 velocity cell. Enter an equal sign to indicate that a formula will be entered. Type 0.5, meaning 1/2 meter. Then type a slash, meaning that we're going to divide. Point the cursor at the average time cell and click it. The cell number will appear after the slash. Now the formula says to divide 0.5 meters by the value of the average time cell. Hit the Enter key and the cell will be filled with the calculated velocity. Now that the case number 1 average velocity has been calculated, we want to know its standard deviation. The ratio of the velocity error to the average velocity will be the same as the ratio of the time error to the average time. So click the velocity standard deviation cell. Type an equal sign to start a formula. Then select the average velocity cell. Its cell number will appear after the equal sign. Type an asterisk, which means multiply. Then select the time standard deviation cell. Its number will appear after the asterisk. Type a slash to mean divide. Select the average time cell. Its cell number will appear after the slash. The formula says to multiply the average velocity by the ratio of the time standard deviation to the average time. Click the Enter key and the number will appear in the velocity standard deviation column. Next, we want to fill in the average velocity and velocity standard deviations for the remaining 3 cases. We do this just like we did for the times. We select the row 1 values and we copy them. Then we select the block of cells below them for cases 2, 3, and 4, and we paste them. Finally, notice that the calculated values display with too many significant digits. Select the 4 cells in the average time column. Click on the decreased decimal icon on the Home tab. Repeat this until there are the same number of digits after the decimal point as you see in the measurements. Adjust the time standard deviation, average velocity, velocity standard deviation, average range, and range standard deviation using the same procedure. The data table is now complete and we would like to transfer it to the lab report, which is a Microsoft Word document. To do this, use the cursor and select the entire table as shown below. Then on the Home tab, select Copy or simultaneously push Ctrl-C. Open the MS Word document and on the home page press Paste or type Ctrl-V and the table from Excel will appear. Then you can use the MS Word table functions to adjust the format as you need. This table will be automatically linked to the Excel table so that whenever both are opened, if it becomes necessary to change a number in the Excel table, it will automatically change in the Microsoft Word table as well. Now that the data table is complete, we will make a graph of range versus velocity. We want this graph to have range on the vertical axis and velocity on the horizontal axis. The graph will have 4 points. We have standard deviation values for both the range and the velocity, so there will be both horizontal and vertical error bars at each point. The point should lie approximately along a line. We want to draw the best fit line through these points, and we want to know the equation of that line. Finally, we want to export the graph to the lab report. The first step in preparing to make a graph is to arrange the velocity values and the range values in side-by-side columns. We make a copy of the average velocity values somewhere on the sheet. Anywhere will do. To do this, select a cell, type an equal sign, and then select the first average velocity cell. Press the Enter key, and the average velocity value will be replicated. To complete the replication of the average velocity, select the cell where the first average velocity value is replicated. Select Copy on the Home tab or type Ctrl-C simultaneously. Select the 3 cells below the first cell and select the Paste on the Home tab or type Ctrl-V simultaneously. The remaining average velocity values will be replicated. Follow the same procedure to replicate the average range values in the column to the right of the replicated average velocity values. In general, when setting up to make a graph, the horizontal values go in the left-hand column, and the vertical values are in the right-hand column. Now that the data is arranged to make a graph, change to the Insert tab at the top of the sheet. You will see that there are chart type options in the middle of the header. Select the 2 columns of replicated cells. We want to make a graph that has data points with an X and a Y axis. To do that, choose the icon for Insert Scatter Chart. Scatter chart options will appear. Choose the one that has data points only. Don't choose ones that have curves or lines in them. When you click it, the chart will appear in the middle of the spreadsheet. Next, let's change the chart layout so that it will be appropriate for use in the lab report. We will need axis labels and a chart title. To do this, choose the Quick Layout icon at the left end of the Chart Tools Design tab header. Select the first option, which is a layout with axis labels and a chart title. On the chart, click on the axis title below the x-axis. A box will appear around it indicating that it is a text box. Type in velocity meters per second. Then repeat the procedure for the y-axis label and the chart title. Next, let's add error bars to the data points. The horizontal error bars will show the velocity standard deviations, and the vertical error bars will indicate the range standard deviations. To do this, begin by selecting the plus sign that is near the upper right corner of the chart. This will reveal a list of elements that can be added to the chart. Check the error bars option, and the error bars will appear on the chart. They'll be arbitrary in length. They have nothing to do with our data. We will adjust them in the next couple of slides. We will want to use the standard deviations from our data table to set the error bars. To do this, click the arrow next to error bars in the pull-down list, and then select More Options. The Format Error Bars pane will appear, and the horizontal error bar options will be displayed. Choose the radio button to display error bars in both the plus and minus directions. Then select the Specify Value box at the bottom. The Custom Error Data Bars data entry box will appear in the middle of the screen. The Positive Error Bar data entry will be highlighted. Select the cells containing the velocity standard deviation values, and the range of cells will show in the data entry box. Press the Enter key. Then select and clear the negative error bar at data entry box. Select the same set of velocity standard deviation cells so that the positive and negative error bar lengths will be equal. The range will appear in the data entry box. Click on the OK button and the horizontal error bars will be set. Now that the horizontal error bars are set, let's set the vertical ones. To do this, click on the symbol that looks like 3 vertical bars near the top of the Format Error Bars pane. That will expose a list. At the bottom of the list, you'll see one that says Series 1 Y Error Bars. Select that. The vertical error bars options will appear on the Format Error Bars pane. We will use the same steps as we did for the horizontal error bars. Begin by selecting the Both Radio button to cause the positive and negative error bars to be displayed. Then select the Specified Value box. The Custom Error Bars box will appear on the screen. The data entry for the positive error bars will be highlighted. Select the 4 cells in the range standard deviation. They will appear in the positive error bars data entry box. Then proceed to the negative error bars data entry box, clear it, and select the same cells. Click OK, and the vertical error bars will be set. Now that the error bars are complete, we want to display the line that best fits the data points. By best fits, we mean a least squares fit. To do this, select the plus symbol to reveal the list of chart elements. Check the Trendline box and a line through the data points will be displayed. It is our plan to calculate the value of the acceleration of gravity, g, from the slope of this trend line. Therefore, we're going to need to display the equation for this line. To do that, go to the Chart Elements line for trend lines, and at the right-hand side you'll see an arrow. Click on the arrow, and some options will be displayed. Choose More Options. This will cause trendline options to be displayed in the pane on the right-hand side. Near the bottom, you will see a checkbox where it says Display Equation on Chart. Click the checkbox and the equation will be displayed on the chart. Let's perform a little housekeeping before we export this chart to our lab report. On the chart, you'll see a legend and it says Series 1. Click on Series 1 and the text box will appear. Delete it. The graph is ready to move to the lab report. When that is done, we are finished. To do this, click on the chart and verify that the entire boundary is highlighted. Then on the Home tab, select Copy or type Ctrl-C. Go to the Microsoft Word document, place the cursor at the location in the text where you want to place the graph. Then click Paste or Ctrl-V and the graph will appear at that location. The graph will be linked to the data source in Excel. So if there is a correction that to be made in the future in your Excel data tables, the graph will automatically adjust. This concludes the tutorial. As we've gone through this exercise, you have probably observed numerous graphing options in the pull-down menus and in the headers that we did not use. When you have some time, you should play with them. The more familiar you are, the more things you can do with these charts, the better the reports you'll be able to make in your future careers.